All right, welcome back, everybody. So this is section 7.5. Now, I will tell you this, the section 7.5, 7.6, and 7.7 and 7.8, that's the second half of chapter 7. These four sections, 7.5, 7.6, 7.7, 7.8. It kind of like switches gears. Normally, I would think that this might be two separate chapters in an algebra book, but they are tied in relatively. But this is kind of switching gears a little bit. Okay? We are now going away from just using exponent properties to polynomials. Okay? Polynomials. Basically, we worked a lot with, when exponents were like multiplied together. Like if I had, x to the third times x to the fourth times x to the negative second, right? What would I do with all of those exponents? How would I put them together? Add them together, right? I would add them together. 7 minus 2 is 5, right? So that's what we kind of worked with before, right? We worked with division, but did we ever really work with addition and subtraction between the exponents? No. So now we're going to start putting addition and subtraction in between the exponents and see what we have to do there. Okay. When we do that, we work with polynomials. Okay. Now, section 7.5, you're going to find that it's a lot of like base material. It's a lot of like learning the language, I like to call it. Learning the language. That means like we've got to learn how to talk about it. We've got to learn how to speak about it. We've got to learn the basics about it so that we can do more complicated things a little bit later on. Now, have we already studied polynomials? Actually, yes. Remember that whole chapter we did with straight line functions? Those were technically polynomials. We didn't really call them polynomials yet, but they technically were polynomials. Okay? And we'll see why here in a second. Now, the most basic form of a polynomial is what's called a monomial. That's that prefix mono meaning singular, monomial meaning one. A monomial is a number, a variable, or a product of number and variables with whole number exponents. Okay? It could just be a number. It could just be a variable. It could be a product of number and variables. That could be a monomial. Pretty much everything that we studied from section 7.1 to 7.4 were all monomials. There were no addition and subtraction signs in there. Okay? Those are all monomials. So let me show you some examples of monomials and then some non-examples. So like just the number 5, that is just a monomial. I don't see any addition and subtraction signs going on. Just x, that is a singular monomial. One term, no plus or minus signs in there. Negative 7xy, I don't see a plus or minus in between the 7, the x, and the y. So therefore it's a single term, monomial. 0.5x to the fourth, yes, you can have decimal, sure, as long as it's multiplied to the variable. 0.5x to the fourth, that's a monomial. What are not monomials then? Well, you can't have negative exponents, that's no good. Okay, that's why I said pretty much everything was a monomial. Negative exponents were not monomials. 4x minus y. The subtraction sign in between there makes it not a monomial. We'll talk about what this is here in a minute. This has a name, but it's not a monomial. It's got two terms, not one term. And then 2 over x to the third. Again, you can't have anything in the denominator. That is technically a negative exponent, right? 2 to the x to the negative third. Now, we're going to be learning this thing called the degree. Okay, the degree. It's a very special number. And actually, you don't understand and you don't learn the full, the depth of what that number means, like the consequences of that number, the full implications of that number, the degree, until like Algebra 2 and pre-calc. Okay, you don't really understand what that number actually does and what that number actually means until a lot later on. So all we're going to be doing here in the near future is telling what the number is. And how do you identify what the degree is? Well, the degree of a monomial is just the sum of the exponents of the variables. Go ahead and underline that. The sum of the exponents of the variables. Okay. The sum of the exponents of the variables. And I want us to point our attention to of the variables. Okay. Is it just a number a variable? No, it's a number, it's a constant. Okay, it's not a variable. So you don't count the exponents of the numbers, you only count the exponents of the variables. So we would say a constant has a degree of 0. because it has no variables. All right, so let's practice that a little bit. Let's find the degree of this monomial. The degree of this monomial. So 4p to the fourth, q to the third. All right, well, my powers here. Now, we understand that we couldn't combine them using anything that we've learned thus far this chapter, right? We can't combine those exponents because those aren't like bases. We can't call that like 4pq to the sixth or something like that. So we have to leave them separate. That is a single term monomial. Okay, so what's the degree here? Well, you take the sum. What does it mean when I say sum? What am I doing? Adding. I'm finding the sum of the exponents of the variables. All right, so I see a 4 in an exponent and a 3 in an exponent. So the degree of this is 7. I'm going to abbreviate degree as DEG. Degree of this monomial is 7, not 8. You might be tempted to say 8 because, we could write a first power on 4, but you don't count the powers on the numbers. You only count them on the variables. 7 ED. What do we think the degree is here? 32. It would be 2. Very good. It would be 2. The power of 1 here, the power of 1 here, with a total sum of 2. Right? And, I say equals 2. We should really say the degree equals 2. Right? Because, again, we're identifying what the degree is. Again, we have no idea what this means yet. That will come. Trust me, that will come. But the degree is a very important number that tells you about the graph of the polynomial. All right, what about 3? Just 3. Singular 3. David? Wouldn't be 1. It would be 0. Because are there any variables? No. So there is no sum. There's 0, right? For it to be 1, it would be like an x to the first. So the degree here is 0. All right. Let's go back to one of these with multiple variables. What is my degree here? 3. Good. The degree here is 3 because it's squared to the first power, total 3. Okay. So finding the degree of a monomial, not so bad, right? Okay, you just add up the powers of the variables. You don't count the number, you only count the variables. Okay, not so bad. I've been talking about how polynomials are going to have more than one term. So what do I mean when I say term? The terms of an expression are the parts being added or subtracted, right? When I talked about combining like terms, the pieces that are being added or subtracted, the chunks of the polynomial. Okay, the terms of an expression are the parts being added or subtracted. Okay, so by definition, a polynomial, and that prefix poly, meaning many, polynomial, like polygon, like polyester, that prefix poly shows up a couple times. But that's I forget whether it's Latin or Greek, but that's a prefix meaning many. Okay, many term is a monomial or sum or difference of monomials. Okay, so this is what I can call it multiple terms. Now, that being said, a monomial is still a polynomial, right? It's still got that branching name. Like, you are all students of like high school, but can't they get a little bit more descriptive and say, okay, you're Mr. Laverick student, right? Are you still students of Lake High School? Yes. So a monomial is just a little bit more specific polynomial. We can say a monomial is still a polynomial, but since it's only one term, we can call it something a little bit more specific. Okay. A polynomial can also be a sum or difference of monomials. Now, how do you find the degree of that, right? We talked about the degree of a monomial. How do you find the degree of a polynomial then? Well, the degree of a polynomial is the degree of the term with the greatest degree. It's the degree of the term with the greatest degree. So what you're going to do is you're going to look at all the terms and you're going to find the degree of each part, each monomial on its own, and then say, okay, the biggest one is 6. So the degree of the whole polynomial is 6. Okay? So let's take a look. Flip it over to the second page here. See, we're flying through this. Flying. Already on the second page. Find the degree of each polynomial. Okay. So do you see how this is three separate terms? Yeah, we see how this is three separate terms. Go ahead and underline for yourselves the three separate terms on your page. 1, 2, 3 separate terms. All separated by addition and subtraction signs. Now, what's the degree of the first term? 7. Just 7, right? Because there's no other variables, so it's just 7. What's the degree of the second term? Just 3, because the power is 3. Not because the number is 3, but because the power is 3. What's the degree of the last term, the constant term? 0. Okay, now, here's where a lot of people make their mistakes. I said by definition the degree of a polynomial was the degree of the term with the greatest degree. Not the sum, but which one is the biggest. So which one is the biggest? The 7. And that's the degree of the entire polynomial. So the degree total is 7. Okay? This one just wins out. The highest one wins out. You don't even worry about the fact that there was another one that was a degree of 3. Okay? The degree of the polynomial is technically 7. And again, you don't understand the implications of what it means that it has a degree of 7. Like I can tell you right now, I know that on either end of this polynomial that it goes up and down, just because I teach Algebra 2. And I know that there are 7 times that this crosses the x-axis, because the degree is 7. I also know, it's got 6 turning points in the graph where it goes high and low, right? You learn all of these things throughout Algebra 1 and Algebra 2 about, okay, based on the degree and other things about the polynomial, you can kind of determine what the graph is going to look like without needing to go to a graphing calculator or anything. Okay, let's take a look at this one then. Go ahead and underline each term for me. Go ahead and do that. Underline each term, and then find the degree of each term. I see 1 here, 1 here, 1 here. So again, 3 terms. 3 terms. What's the degree of my first term? 3, right? I see a 2 and a 1 power, right? I see a w squared and a z to the first. So this is a degree of 3. What's my degree of my second term? 4. It's nice when it's just a single variable, right? You don't have to worry about adding or anything like that. And what's the degree of the 5? 0. A lot of people might try to tell me 5 because the number is 5. No, it's the degree of the variables. Well, there is no variable, so it's 0. So what's the degree of this entire polynomial? 4. 4. Yeah.
I got paper towels with that.
What's that?
Paper towels with that.
I don't have paper towels. Did you?
Really?
I mean, there's some tissues back there. Do you want to run to the bathroom, Mr. Victor?
Yeah.
Okay.
Yeah. I have a question.
Yeah.
What if the Z was like a 2 and it was 4 and 4? Would it just be 4 still?
It would just be 4. Great question. What would happen maybe if this was z squared as well? That's what he asked. Is that another example? Oh, well, we'll talk about that in a second. But if it matches, then you just take 1. Yeah.
What would happen if, like, on the line that's like the 3 and the 4, what if the 3 was a 4 and it was 2 4?
That's what he was asking. And we do just take 1 of them. And we'll get to one like that. Okay, so 5x minus 6. Now, this is just linear, right? This is something that we talked about for like a whole chapter earlier on this year. Like 5x minus 6, that's just slope-intercept form. Y equals 5x minus 6. So this is technically a polynomial. Right? Everything that we've learned so far, it's coming back again. So 5x minus 6. What's the degree of this polynomial? 1. Because the degree here is 1, the degree here is 0. So we know the total degree of the entire polynomial is 1. Again, the rule is the degree of the biggest degree out of all the terms. Okay. Let's take a look at that last one, the one that we were talking about before. Okay, so it looks like here, underline all your terms. It looks like I've got 4 terms in this one. I've got 4 terms. And notice here that my first 2 terms, this is what the question was. I've got a 3 and a 2, a 5 here, a 2 and a 3, a 5 here, a 4 and a 0. Okay, so what happens when the degrees match? Well, you just take one of them. So you say that the degree of this entire polynomial is 5. Yeah, they're not going to cancel. It's still technically 5. Okay, questions about that one? All right. Now, the terms of a polynomial may be written in any order. However, polynomials that contain only one variable, and this is important when it only contains one variable, so like it just contains x, or it just contains y, or it just contains z's, or something like that. If it only has one variable, then you can write it in what's called standard form. You can write it in what's called standard form. Now, standard form is written with the terms in order from greatest to least. Go ahead and write that, underline that for me. In order from greatest to least degree. That's standard form. Do you need another set of guided notes?
Yeah.
Okay. Standard form is in order from greatest to least degree. So basically, if it's only got one variable, you're basically going from highest to lowest power. Right? Because the biggest power is going to be the biggest degree. And then you keep going down and down and down, and then you keep getting smaller and smaller in terms of the degree, which means it's getting smaller and smaller in terms of the power, because there's only one variable going on. Also, one other thing, when it's written in standard form, you can identify what's called the leading coefficient. Again, another number that you'll learn the implications of a little bit later. Okay, the leading coefficient is just basically the number in the front of the polynomial. It's the one that leads the polynomial, leading coefficient. Coefficient, it means the number multiplied to the variable, so leading coefficient. Remember that a variable written without a coefficient, so if it's just like an x squared, what's the number right in front of x squared? A 1, right? So if there's just a number or just a variable leading the whole thing, you could say that the leading coefficient is 1. All right. So let's try this. Go ahead. Take a look down there at the bottom of the second page. Write the polynomial in standard form, and then we're going to give the leading coefficient. All right. Okay. So what's the highest degree? What's the highest degree? It's 5. So let's put this degree, this highest degree, first when we write it in standard form. Negative 7x to the 5th. That should come first. What's the next highest degree? 2. So we'll put the 4x squared next. Okay, we've gotten this one out of the way and then this one out of the way. What's the next highest? Well, the 6x, and then we'll write the 9. This is what's called standard form. When it goes in order from biggest to smallest in terms of the power. Again, you can only ever do this when there's only one variable. It would be like an invalid question if I asked you to write something in standard form and I gave you a polynomial that had 2 variables. That wouldn't make sense. You can't do that. Okay, I made the question wrong. Now, let's say, okay, let's identify the degree as well. So we said it, we went with the biggest degree, it was 5, right? The degree here is a 5. The leading coefficient, I'll abbreviate leading coefficient as LC. The leading coefficient of this polynomial is what? What is it? What's the leading coefficient? Well, negative 7. Because technically, if I want just the coefficient, I am only asking for the number that's multiplied to the x term. So I look here and I say, okay, the leading coefficient, the one that's in front, negative 7. -7. The leading coefficient is -7. Again, another number that you don't understand the implications of yet. You'll get there.
Is it just the one that's always in front?
The one that's always in front after you put it into standard form.
Is the leading coefficient?
That's the leading coefficient, yep. And that one has a lot of implications on how the graph looks as well. All right, let's take a look at the next one here. Y squared plus y to the 6 minus 3y. All right, well, the highest degree is what? 6. So let's put that one first. Y to the 6th. Okay, that one's out of the way. Only got 2 more left. Y squared coming next. And then minus the 3y. So the degree, the highest power on y is 6. And what's my leading coefficient? 1. Be careful with that one, it's 1. Okay, that's my leading coefficient. Please understand, never give me a leading coefficient with a variable. If you wrote on a quiz or test, the leading coefficient is y to the 6th, I would have to mark that wrong because that's not technically correct. The leading coefficient is a number being multiplied to the variable, not the variable itself. The number being multiplied to the variable, not the variable itself. All right, try the last one on your own. Try C on your own. Once you've got it written in standard form, identify what the leading coefficient is, and identify what the degree is as well. Okay, highest power is x to the 5th, right? So that should be written first. I like to cross them out as I go, just to make sure I don't miss any terms. And then what comes next? Will?
9x to the 3rd.
Good. And then what's next? Good. And then we have our 16. All right, so my degree, my biggest power, the power that I started with was that x to the 5th, so the degree is 5. And what's my leading coefficient?
1.
1. Good. 1. Because I have a 1 sitting out here in front of this x to the 5th. Okay, so we have identified degree. We've identified leading coefficient. We aren't really sure what those do just quite yet, and we'll get there. But now we're also going to talk about the number of terms as well. Some polynomials have special names based on their degree and the number of terms they have. It's very easy to identify how many terms each polynomial has, because you know how I was asking you to underline each one? That's just how many terms it has. Okay? Now, what we're going to learn on this page is very important. We're going to learn how to name these polynomials, because if it has to give a name, it can tell certain things about it. So, first thing that we're going to look at is looking at the number of terms. It's got one name for the number of terms, and it's got another name for the degree. Okay, so if it has one term, we've already talked about it, it's a monomial. One term is called a monomial. One term is called a monomial. Some examples, just a 2x, just a 5, a 4x squared. Right, those are just single terms, no plus or minuses. Okay, mono meaning one, 2 terms, binomial, like a bicycle, 2 tires. Why does the bicycle have to take a nap? Is it too tired? No. Hey, why do math teachers need glasses? Because it helps with division. Division, we get it? Division. So, 2 terms is a binomial. 2 terms is a binomial. So, like 3x plus 1, that's a binomial. 2x squared minus 4, that's a binomial. Those are good examples. Just 2 terms, right? If you see 2 terms, you can call it a binomial. What do you think about 3 terms?
Trinomial.
Exactly. Trinomial for 3 terms. Like a tricycle. 3 terms. So like 2x squared plus 4x minus 1. 6x to the third minus 2x plus 7. Those are examples of trinomials. 3 terms. I'm not really caring about the powers just quite yet. The next table will worry about the powers. Now, anything beyond 3, you just call it a polynomial. Okay? Anything beyond 3, it doesn't have a special name. You just call it a polynomial. You could call it like a 4-term polynomial if you really wanted to get fancy, if you really wanted to get specific. But you don't need to do that. And then we have, I don't want to do that screen share yet. And then we have by the degree. And then we have by the degree. So it's got 2 names, right? Kind of got like a first name and a last name. The degree, if it's a degree of 1, or sorry, excuse me, a degree of 0, it's called a constant. Because what has a degree of 0? Degree of 0. Just a number. Just a number, like the number 5, the number 7. No variables, right? Just a number. And actually, when we graph it, that's kind of right. When we graph it, it does turn out to be a horizontal line. Like y equals 5, horizontal line. Y equals 7, horizontal line. Okay? When you've got a degree of 1, you call it the linear. And we've done a whole chapter on that. We've done a whole chapter on linear function. Linear function. So like 2x plus 3. Just like 4x. That would be called a linear monomial. Because it's linear, it's got the degree of 1 term, monomial. Degree of 2 is called a quadratic. Chapter 9 is an entire chapter on quadratics. We spent an entire chapter talking about quadratics. So everything where it has an x squared. So like 7x squared plus 2x. 3x squared minus 4x minus 1. Those are examples of quadratics. I don't really care about the number of terms. If it's got a squared term, and that's the highest one, that's what's called a quadratic. Third is cubic. Cubic. Like 3 dimensions, like a cube. 4x to the third power. 7x to the third plus 2x squared minus 4x plus 7. Those are examples of cubic functions, cubic expressions.
What makes them like that?
The third power.
It just has a 3 power.
It has the highest powers of 3. See, this first one here, I would call that a cubic monomial because it's only got 1 term. This one over here, I would just call that a cubic polynomial because it's got 4 terms, and 4 terms doesn't have a special name. Degree of 4 is what's called a quartic. Quartic. I remember this one because how many quarters in a dollar? 4. 4 is quartic. So you would say like 7x to the 4th power minus 2x squared, or 3x to the 4th minus 2x squared plus 7. Those are examples of quartic expressions. The first one would be a quartic binomial. The first one would be a quartic binomial. The second one would be a quartic trinomial. Anybody in Spanish here? What is 15 in Spanish? Quince, right? This is quintic. You know, maybe my Spanish speaking friends would say quintic or something like that. But doesn't that look a lot like the word quince? Q-U-I-N. Not many words start with Q-U-I-N, so I would say yes. Quintic. We would say that in our American language, quintic. Quintic. That's degree of 5. Okay, so like 4x to the 5th, or 7x to the 5th minus 2x. Those are quintic because they have a degree of 5. Anything beyond that, you call it like a 6th degree, or a 7th degree, or an 8th degree, or so on. They don't have, they have generic names beyond 6. Okay, so let's name these things. So let's classify in terms of its degree and number of terms. Let's identify the degree and number of terms for each one. Well, what's the degree of this one? 3. The highest power is 3. How many terms does it have? 2 terms. Okay, so degree of 3, what is that? Cubic. 2 terms, what's that? Binomial. Binomial. So we would call it a cubic binomial. Okay. We would call that a cubic binomial. Take a look at our next one. Again, do the same thing. The degree and the number of terms. What's the degree here? How many terms do we have? Okay, so this one has the generic names. We would call it a 6th degree. And 4 terms, polynomial. 6th degree polynomial. If you wanted to get real fancy, you could call it a 6th degree 4-term polynomial. Let's take a look at our next one. What's the degree of that? 1. Please don't say 0. It's 1. It does have a variable, so it's 1. How many terms? 1. Okay, so let's look at the ones. That's a, sorry, not constant. It's a linear monomial. Go ahead and name the last one. Okay, what's my degree? David? 2. And what's my number of terms?
3.
So what would you call this, David? Good. Quadratic trinomial. Quadratic trinomial. All right, last one here. I'm sorry, I'm not going to give you like hardly any time to work. I'm so sorry. The polynomial is used to estimate stopping distance in feet for a car whose speed is v miles per hour on flat, dry pavement. Yeah, stopping distance, and this is how they calculate like how long like yellow lights need to be, because they need to calculate how long that would need to make you stop. It says, what is the average stopping distance for a car traveling at 70 miles per hour? 70 miles per hour. Well, if v is my velocity or my speed, what do I have to do with this 70? What's that really asking me to do? Just plug it in for v. So this is saying, okay, 3.675 times 70 plus 0.096 times 70 squared. So we would say 3.675 times 70, put it right as I see it on the page, plus 0.096 times 70 squared. So I would say if you're going 70 miles per hour, you need about 700 feet to stop safely. Okay, 726, what did it say to the nearest? Oh, it didn't say to the nearest. 727.65. 727.65 feet. That's the safe stopping distance. I know this might seem like a lot of homework, but this is just like, a lot of it's just like, what's the degree, what's the degree, what's the degree, what's the degree? What's the term, how many terms, how many terms, how many terms? So it's just giving you repetition on those types of things. Okay. Again, you can check, online for your quiz grades, if you wanna see that. I'll probably hand those back on Monday, once I get everybody's grades.
John, how's the tax?
Oh, I gotta turn off the video. Almost forgot.
You like?